Welcome to Park Knowledge Platform. Today our topic is Coulomb's Law. Subscribe our channel. Your subscription motivates us for more hard work. Coulomb's Law. The electric force acting on a point charge Q1 as a result of the presence of second point charge Q2 is given by Coulomb Law. These are two charges Q1 and Q2. If they are like charges, then they repel each other, and if they are unlike charges, then they attract each other. So force between these charges F is equal to kq1 q2 over r square, where k is equal to 1 over 4 pi epsilon naught, where epsilon naught is equal to permittivity of free space. K is equal to 1 over 4 pi epsilon naught is its value is approximately equal to 9 into 10 power 9 Newton meter square per Coulomb square. This is also called Coulomb's constant. We will explain the Coulomb constant later. Coulomb's law. This satisfies Newton's third law because exactly the same magnitude of forces acts on Q2. Coulomb's law is a vector equation and includes the fact that the force acts along the line joining the charges. Like charges repel and unlike charges attract each other. Coulomb law describes a force of infinite range which obeys the inverse square law and is of the same form as the gravity force. The constant of proportionality K appearing in Coulomb's law is often called Coulomb's constant. Note that it can be expressed in terms of another constant epsilon naught, which is permittivity of free space. When describing the electric forces in atoms and nuclei, it is often convenient to work with the product of Coulomb's constant and the square of the electron charge since that product appears in electric potential energy and electric force expressions. The product in unit appropriate for atomic and nuclear processes is Ke square, where K is 8.9 into 10 power 9 Newton meter square per Coulomb square and E is the electron 1.6 into 10 power minus 19 Coulomb whole square. E is the charge of electron. So multiplying these we get 1.44 mega electron volt. The electric force between charges may be calculated using Coulomb's law. Many of the examples are in our daily life. We can calculate electric force between the charges using this Coulomb law. Thank you for watching our video. Subscribe now for more videos and press bell icon for our daily videos. Thank you.